All right, we'll try that again. Hi everyone, I'm John. I am the webmaster for White Hat, and I'm here to talk about virtualization and virtual machines. So what is virtualization? Virtualization is pretty much when you take any physical resources and synthesize that into something more software related. So basically you take your physical resources like your RAM, your CPU, storage, your NICs, which are network interface cards, and you basically replicate those in a more digital fashion, so then you can pretty much control what you want to use those resources for. So it allows you to scale physical resources into a lot more use cases than just, I have an operating system like Windows and I want to use my storage and RAM to process only in that. With virtualization, you can basically be like, I want to give like 1 gig of RAM to Firefox running in this browser in this operating system and use that for another case in, like, say, creating a web server or stuff like that. So that's kind of like the basics. Generally, virtualization also utilizes things called a hypervisor, which I'll talk about, and basically the goal of it is you go from running on just a standard computer where you have your hardware, operating system on top of that, and then your programs on top of that. That's like before virtualization. When you use virtualization, you have your hardware. That goes into another virtualization layer, which is called a hypervisor. And then from there, you can duplicate or split up your hardware into like different portions of RAM and storage that you want, and then on top of that, run more operating systems and applications inside of that. Does anyone kind of understand where I'm going with that, just initially? Okay. So taking that concept of virtualization, you have these things called virtual machines. So what is a virtual machine? Well, it's a software container or an operating system that inside of that runs a hypervisor, which inside of that, then you can run other operating systems or programs or applications as well. So a hypervisor is pretty much a layer of a layer of code built into what's called the kernel in most cases. And in there, it allows you to have virtual machines be present. There's certain types of hypervisors. Some are built into software applications. Others are built into kernel modules called most specifically called KVM, and that's where the hypervisor itself can be implemented directly into Linux kernel modules.
So is VirtualBox a hypervisor?
VirtualBox operates on top of a hypervisor that it installs. VirtualBox would be the management software the management software that runs a hypervisor to then run operating systems inside of VMs.
Okay,
inside
so
of it.
I'm installing VirtualBox. I'm managing some hypervisor that is installed on my operating system.
Correct.
And then that hypervisor is managing my VMs.
Yes. Yeah. So VirtualBox is just a software application on top of that kind of automates the creation of a hypervisor and stuff like that. And the same with VMware, and I will cover those as well. For this talk, so I'll be mentioning a few things. I'll be mentioning host. By the word host, I mean the physical computer or server that you're using. So like this Mac would be considered the host machine. And then any virtual machines I run inside of that, I'm going to be calling those guests because they're taking up a portion of the host computer, but they're not fully running all of that. It's just like some of the language pertaining to virtual machines, but that's kind of how I'll be going through this a little bit. And also OS, just in case you didn't know, means operating system. Yeah. So initially, virtualization started in 1966 with the IBM CP40 and CP67 operating systems. And those were kind of like the first endeavors into virtualization where IBM basically, for research purposes, determined how to fully run another operating system inside another one. But there was some caveats, like they had to be the same CPU architecture because they had to use the same instruction set and things like that. but that was at the very basic stage. And this was also designed for very, very enterprise usage and also for research purposes. From there, in 1972, the VM370 kicked off as the first official operating system for virtualization offered by IBM, and this was more targeted towards consumers, but even then it was a lot more enterprise related and not really available for like us in general. Then Intel and AMD added hardware capabilities into their CPUs, which have now made it into into pretty much all of our CPUs for hardware support for virtualization in two camps. One is VTX for Intel and AMDV for AMD. Basically, these are really good features because without them, we wouldn't be able to do VMs and virtualization. And nowadays, they're just everywhere. VMs are literally used in a lot of applications, whether in virtual private servers, such as AWS, or in Docker containers, which I'm going to go into, or using Vagrant, VMware, just a whole lot of features. And also, like, lots of companies use those, such as GitHub. Most likely they use a bunch of VPSs to spin up for storing your code in a bunch of repositories that they can then have access to and such. A VPS I will cover, but it is a virtual private server. It's just the fancy little acronym for that. So virtualization, like the architecture of virtualization. So I kind of went into this, but so first you have the host machine. And so the host machine does all the work pretty much. That's where all of your hardware is at, your RAM, storage, with your hard drive or SSD, your CPU, pretty much everything's inside of the host machine. That's where all the resources are from. From there, you have your operating system. And this is running on top of the host machine's hardware. And that's pretty much like Windows, Mac OS, whatever you choose to use, or Linux also is an operating system. From there, you have the hypervisor. So this is where it runs on top of your own operating system, or it can run as your operating system, which is kind of an interesting distinction. But that is then what allows the guest VM to then run on top of the host machine. In addition to that, the hypervisor also can bridge the two, so then you can share resources. So any files that you have inside of your host machine, you can also access in the guest machine, and you can also share the same network, or you can choose to not share the same network. A lot of things like that, and also RAM is shared too, of course. Though you don't want to use too much RAM because then that gets offloaded onto your hard drive, which is not fun. Within virtualization and virtual machines, there's also several implementations. So there's server-sided implementations, network virtualization implementations, program and application implementations, and desktop virtualization as well. With server virtualization, this is where where primarily the main portion of virtualization goes into virtualizing servers for consumers, like us pretty much. So a big use for developers is virtual private servers, which is what VPS stands for. These would be Amazon Web Services, as most of you probably are familiar with, or at least know of Amazon. Also DigitalOcean, which is a more niche offset of them, but there's also cool things with DigitalOcean, like you get a good amount of credit through them for the GitHub Education Pack, which plug for the GitHub Education Pack, because that's pretty cool. And then in addition, there's also VMware ESXi, which is kind of consumer, also more towards like prosumer / enterprise level. And that is an operating system that then can run virtual machines inside of it. So that's actually probably what the CSL on their Unix machines uses. And most of you, if you're in a CS class, you've connected to the Unix machines. You kind of know what those are. If you don't, they're machines that are running a version of Linux that computer science classes use and take advantage of here at Cal Poly. And those machines are not necessarily all physical servers, because if they were physical servers, there'd be a lot of added cost for resources, or there'd be too much extra power in those machines that is wasted because they wouldn't be fully utilized. So from there, it would be better to virtualize servers on top of those and take your existing hardware, which would be like probably very capable, and just run 4 servers on one server, for example. And that also reduces power and heat costs of just sticking a bunch of servers into one server rack and just having that noise as well, which isn't great. And also, as I said, it fixes underutilization of powerful hardware such as Xeon CPUs or fun stuff like that, where all that hardware is dedicated to one operating system, when instead you could just run like 10 or like 20 if you wanted, however much you wanted. With network virtualization, this is where it gets pretty weird very fast, because you're basically trying to replicate networking strategies digitally when there's physical hardware to do the same thing, but like you don't have that hardware because you're not like a big company like Cisco. So one thing for that is VLANs, which are virtual local area networks. So if you've heard of LANs, this is the same thing except virtual. So basically, you have a bunch of machines. Like say you have like your phone, your desktop, your laptop, different computers, and you want them all to be able to connect to each other. But they could be on different networks or on like a weird network architecture, like a certain wireless, just like all over the place, kind of. Or like one machine's in your dorm or one's like off campus, a whole bunch of weird things going on. And say you don't have access to the router configuration itself, so you can't be like, oh, I want to like SSH into my desktop, but I can't do that. SSH is remote logon, in case you didn't know. A way around that is to install a VLAN service, which would then, those machines route their traffic to a virtual server, which then would act as a router connecting those machines together, no matter where they are on different networks and such. As long as the port that the VLAN service goes through is open, then theoretically it acts as one big hub where those machines can connect to each other. So going off of that, a VLAN is kind of a wide area network, but virtual, which is kind of also a bunch of LANs that are connected together, or VLANs connected together, and they can talk to each other. So currently, it doesn't seem like there's many implementations of this. I found this on a Microsoft page, but like, who knows? Because it's Microsoft. There's some weird things on there. But it looks like you could have multiple machines connecting to a virtual LAN. From there, the VLANs would talk to each other and form a network within themselves. And then the machines connected to one VLAN could talk to another one through connecting to that VLAN, more or less. It also could not be the case of that as well. It seems like it's not really used, at least not publicly used, but it's an interesting concept as well.
Is this like Hamachi?
So Hamachi would be a VLAN service. This would be like connecting Hamachi networks to each other and then having those all connected together. In addition to Hamachi, Hamachi is a program offered by LogMeIn, which is the makers of LastPass, and it does it does VLAN services, so multiple computers can connect that way. There's also Zero Tier, which is a really cool VLAN service as well. That's very overpowered from a networking standpoint. Then there's also virtual NICs. So network interface cards are like a physical network card that's plugged into your machine. So whether you have like Wi-Fi on your computer or an Ethernet port, those would all plug into a NIC. And from there, not you, Nick. From there, on a virtualization standpoint, the hypervisor would interact with that NIC and form a vNIC. From there, that would be how virtual machines can have networking from that. So it kind of acts as not really man in the middle attacking, or intercepting your traffic, but it more acts like a router. So all the traffic from the virtual machines goes into the VNIC, and from the VNIC, basically, that processes the correct locations where they're trying to go through the network interface card itself, and basically makes them reach their destination. So if you're trying to access, say, Google in a virtual machine, it'll go from the VM to the VNIC, and the VNIC will be like, okay, this VM, which has this unique identifier, is trying to connect to Google. So I'm now going to route that to your physical card and then have that pass it off to Google. So the mode that does that is called network address translation, otherwise known as NAT. For VMs, that works on a basis of trying to keep the VMs connected together in one combined network, but it also allows them to connect out to Google or other services as well. But they can't access other machines on the same network as you. On the other hand, there's bridged Ethernet, which is where a virtual machine would bypass the VNIC in having that route its traffic, so it would be connected theoretically to the network that you're connected on. So kind of confusing, the little differences, but say you have a virtual machine and you want it to be connected directly to Secure Mustang. You could connect it over NAT, but it wouldn't have its own IP address or address for the router to connect to. It wouldn't appear to the router. It would appear underneath your computer if it's in NAT mode. But if it's in bridged mode, it would appear as another computer on the network.
But with the same IP address?
With a different IP address.
So in bridged mode, the virtual machine has its own IP address?
Correct, yeah. Because so when it's bridged to the network, it connects to the network as if it is a physical computer on the same network. So it has a different IP.
So if you had two wireless cards, could you connect your virtual machine to one Wi-Fi and your host to another?
Theoretically, you would pass the Wi-Fi card into the virtual machine itself, so then it would have the physical hardware to connect to that way.
So Nick, I think it's like trunking on switches, where you can pass multiple IPs through.
Yeah, it is. Well, it's VLAN, so it's trunking.
Mm-hmm.
The question is, can you use that to assign multiple? Like now, is my one machine making 10 DHCP requests? Because
one Nick could theoretically, if you're trunking like that.
Yeah, I guess.
Theoretically, I think it would be, but there's also some things that are going on between the physical NIC and the VNIC in routing those in the back end. Yes, yeah. And there's also virtual private networks. So these differ from the others where the other three are more emulating hardware implementations of networking components, whereas VPN or a virtual private network is applying encryption to your traffic to say Google. So then your ISP or anyone else on the network can't see where you're connecting to. So this adds an extra layer of security and isolation from your data in pertaining to your machine on the internet as well. And from there, it sends your traffic to another provider who then routes your traffic to where it's supposed to go. So if you're connecting to Cal Poly, you could connect using a VPN, and anyone on this network wouldn't see that you're connecting to Cal Poly. They would just see a bunch of encrypted text. But hopefully, the VPN provider is also using a good layer of encryption and connecting back to Cal Poly. Otherwise, you'd result in this image where it's unencrypted. So anyone trying to steal your information or snoop on your traffic would just be able to be oh, there's this connection. That's coming from this server. But if you were, say, logging into a page with your credentials, they could capture that information, and then that's one piece of correlation back towards you, which provides a or which keeps your data, which helps make your data not private if someone else is able to catch it, pretty much.
Wouldn't whoever's routing the traffic be able to tell that you're sending traffic to the VPN provider? They just wouldn't be able to tell what it is?
Yes. They see a large amount of traffic going out to some address, and most VPN providers have a bunch of servers in different locations that are just IPs. So they could see that traffic, but they just wouldn't know what it is, and it would theoretically blend in with other traffic to IPs and such. And you can't restrict traffic to IP addresses because that would not be a great idea. Do you have a question, Nick? Or, okay, yeah. The third type of virtualization is program or application virtualization. This is also known as para-virtualization in some parts. Also, that's like kind of a more like interesting term, but yeah. So it basically means that there's no real hardware virtualization. You're basically just applying isolation to whatever you're trying to run. The core service that uses this is Docker, and Docker is a framework that or a program that you install on your host machine. It creates a hypervisor called the Docker engine, but it's basically a hypervisor. And from there, it runs containers. These containers are standalone in the sense that they're not running an operating system. They're actually running images which are created to mimic an operating system, but they have like no packages installed. So this is nice from the sense that you can program those to have what you want installed on it, and also you can do that through a Docker file, which is programmatically created and can do a lot of scripting based off of that. And it's also nice for packaging code with its dependencies, for if you're a developer building stuff, or if you're also just trying to distribute your code nicely, pretty much.
Based on that picture, if you're not using a Linux host, is there actually more overhead for Docker?
So where I found this image, yes. However, it appears that way. In terms of my own practices, there's actually not too much overhead. Especially in comparison to a VM itself, there's very little in comparison differences in performance, pretty much. But yeah, going off that, on Linux, Docker just runs, and when you install it, and it doesn't have to do any crazy like hypervisor magic in order to get itself to run. But on other operating systems, Docker has to run a hypervisor first, and then Docker, and inside of that is the Docker engine running as well.
To the point of efficiency, if you have multiple containers running, they're still only running on one OS. So whereas with a virtual machine, you need to run multiple OSs to run different things in containment. In this case, Docker will run them all on the same VM, so it's a little more efficient.
But in the case of a non-Linux environment, do you still have to run you still have to run Linux? You still have to run some kind of guest Linux, right?
Yes, except when you install Docker, it just comes pre-built inside.
Okay.
So it just sets all that up for you, pretty much.
And responding to that, when you install Docker on Windows, there's kind of two ways of installing it. One where it sets up a virtual box or virtual machine to run the host Linux OS. The other way is if you have Windows Professional, I think it can use whatever the Windows virtual, Hyper-V, to run a Linux-based OS. But otherwise, it does spin up a base VM.
And I think on Mac OS, it's a lot more seamless, and it doesn't have to do VM magic to make that work. But yeah. And so some of the reasons why you want to use Docker is for, say you want to just spin up a website. Well, normally that would be a lot of work because you'd have to spin up a virtual private server or spin up a VM itself and then put Linux on that and then put Nginx or Apache on that and a whole bunch of things. But with Docker, all you can do is you could just be from the Nginx image, I want to run a server, or from the Flask or from the Python image, I want to install pip and then use pip to run like Flask and serve a web server from there. So it's a lot more seamless and a lot less steps to get a web server up and running. In addition, also you can develop and build packages a lot with theoretically less errors because you won't have to deal with different environments and messing around with that. And you can also just ship Docker containers and then use those to build your own software if you're trying to have just anyone open source build your software from scratch pretty much. The final type of virtualization is desktop virtualization. And this is a very fun thing to do because basically you install a program on your computer and that program runs kind of a virtual desktop infrastructure, also known as VDI, which works with a hypervisor to separate the host desktop environment from other operating systems that you run on top. And the cool thing with this is you just install a program, and if you don't like doing virtualization, you can just uninstall that program, and as well as also deleting the virtual machines that are stored on your computer. Nothing affects your own host operating system. So among different desktop virtualization programs, there's VirtualBox, VMware, and and Hyper-V from Microsoft, but that costs like an extra $150 to have for Windows. But the really cool one that we as Cal Poly students have access to is VMware Workstation, which is their like $300 professional program that we managed to get for free through On the Hub. And this is a really cool program because it's basically targeted at prosumers/enterprise users, and allows you to do virtualization at a much more efficient rate, in addition to also having several nice features. Some of those are shared folder synchronization with a lot more ease, I think, than VirtualBox. And this is nice because you can basically take a folder on your host operating system and be like, okay, I want, say, Linux running on my machine to also have access to the resources there. So I'll just share, like, say, documents to that machine. That machine can either choose to only read the documents inside, or I can give it permission to also modify those files. So from there, you could theoretically just have an open tunnel between the virtual machine and your own host where they can modify things inside. In addition, there's also remote server connectivity built into Workstation. So if you have like a desktop machine that has a lot of processing power, you can have Workstation there and then use your laptop and remotely connect to that and have the desktop do all the hardcore processing and have all of your resources, and the VM can and your laptop can stream the VM content over, pretty much. And there's also some advanced VM configuration things, like being able to unofficially install macOS on VMware using some hacks, kind of, and also spoofing your motherboard ID and like other hardware-related identifiers, which the VM could see and potentially like gain information from about your own computer. And you can also like modify your MAC address easily that way too. Did I? Okay. Yeah, it's very unofficial, but it works by patching VMware, and then you do some stuff.
Politics on VMware's side because they want to work on it.
Yeah, pretty much. So that's kind of Workstation. And what's cool also is this service called Vagrant. So Vagrant's cool because it allows you to program and interact with VMware and VirtualBox's APIs just by writing a few simple lines of code, and then you can spin up a VM that way. So using what's called a Vagrant file, you can basically be like, I want this VM called, like, say, Cyber to have like 2 CPU cores and like a gigabyte of RAM. And then when I run this command, I want you to do that right now. And I also wanted to run this script after it finishes getting set up. That'll then, like, say, set up an entire web server from scratch. So you can do all that with lines of code and then just run one command and it'll do all of that programmatically, which is very nice when you're trying to spin up VMs using Vagrant from other services like Python or stuff like that for a lot of automation purposes. So with all this information, why would you virtualize? So the main reason is, or one really good reason is using your physical hardware to do a lot more with it than what you could do if you didn't virtualize. So like if you have like a bunch of RAM, but you're like, I don't want Firefox to take up all my RAM or like Chrome to use all that just for like 5 tabs. Instead, I could just run more web servers in VMs and play with websites and do stuff like that. And if you have really powerful hardware, you could split up that hardware into making like more normal sized computers on the same machine, kind of playing around with different environments. And also you're not just limited to using Mac OS or Windows or Linux. There's really like kind of no excuse to not know all of them. If you're like, oh, but I don't have a Windows machine, you could just spin up a Windows VM and then there you go. You have a Windows machine on your Mac machine. So you can kind of play around with that and get to know other environments. Going with other environments, you can also have consistent development environments across different OSs. So if your program works on Mac OS, you can also test to make sure it works on Windows and Linux if you're trying to hit cross-compatibility. And you can also then see different edge cases like, oh, does it work on Windows 7? Does it work on Windows 8, Windows 10? I guess not Windows 7 because that's EOL pretty soon. But you can do things like that and test different builds or even different versions. Like, does the latest version of Microsoft delete, or for the latest version of Windows 10 from Microsoft, delete all my files? Or like different things like that. It's a thing. It's now not a update anymore. But also, you could theoretically have no more downtime. Like, if your server crashes, like, then all you do, if it was in a virtualized environment and you had a snapshot of it, is you just restore said snapshot to your server. And then you're happy again, and then you're fine. But like, if you didn't, then you'd be sad, and that wouldn't be great. Or you can also use some special virtual machine stuff to restore a virtual machine to a physical machine. But that's a whole different crazy thing. So, yeah. For security purposes, there's also a lot of really cool things. So you can have isolation between the host machine and the guest machine. And from there, you can like have separation of personal data, which is always a good thing because you don't want everyone on the internet being able to have access to say where you've been going. Like if you've been looking on Facebook and then go into, say, Twitter, and you don't want Facebook to have access to that information. And in addition to that, you can also then, with VPNs and such, protect your data because what you've done or what you've been browsing on is private to you, and other companies shouldn't be able to just be like, I'm going to take that information without like you saying sure, and then working with that. You don't want tailored ads all over the place, most likely, unless you really do, but even then you should have the choice to say. In addition, also, the snapshots is a really cool feature for VMs. Doing malware analysis myself, if I didn't have VMs, it would be very hard to run malware and see what's going on with those, because then I'd have to go through a lot of computers doing that. But with VMs, you can just roll things back, and then boom, you're back to, like, say, how you installed Windows 7 before you started running like WannaCry or stuff, or hacking it or breaking Windows 7 or whatever. But yeah, that's pretty much virtual machines and VMs. Does anyone have any questions?
So you said that you could run malware on a virtual machine. Is there any way for that malware to then affect your host computer?
So if you didn't employ the right like security techniques, yes. Like for example with shared folders, if you had shared folders enabled, the malware would see that as a mounted drive and be like, oh, cool, I'm just going to propagate myself into this network attached storage, and then boom, it's on your host machine. Which is also why if you're working with malware, like Windows malware, it's probably best to do that on a Mac, just in case the malware happens to get out of the virtual machine environment. The chances that it'll survive on a Mac OS environment is also very slim. And most virtual machine providers are also very up to date on making sure that that part is super secure, because a lot of malware researchers do that.
Did one of the Spectre attacks have a VM escape vector in it?
I believe so. Yes.
Or did it
Yeah.
run through JavaScript and
Mm-hmm.
Do you mind? Yeah. Spectre 1 is can break hypervisors. So there's two variants of Spectre, and the first variant, which is called Spectre 1, specifically is really good at, if I am in a VM, I can read the memory of my host machine.
So you said you can run like malware in a virtual machine.
Yes.
If I was a malware creator, which I'm not, but if I was, step a little closer to this my shirt right here. Is it possible for me to detect if my software is running in a virtual machine and just like do nothing so that no one can research my malware?
Yes, it's actually very easy to do that. There's a lot of checks that some good malware authors put in place. So you can check if VMware tools.exe is running, for example. You can also check if, I think if it exists in like program files. There's also other checks where you can check a lot of the OS metadata. Like VMware sometimes reports like graphics data as being like VMware adapter as your graphics card, but that's not a real graphics card. So there's a lot of things that malware authors check at in order to try to determine if they're running in a virtualized environment. But then on the other hand, if you're trying to reverse engineer said malware and like understand what it's doing, and you can run it in a debugger and then basically just skip those checks.
But yeah, to go on that, even if you were really careful, there's some checks that malware can do, like checking the clock of your CPU, because in a VMware, it's typically very, very stable. Just checks like that is very, very difficult for a virtual machine to hide.
What are some projects where you've actually used a virtual machine yourself?
So actually this past summer, I was working on an internal tool at the internship that I was at that only worked on Windows, but they wanted me to make it work on Mac OS, and I could have done some things to like try to make it work just like out of the box, but another solution is just automation in order to spin up Windows and just run it in there and then get the data I needed from that. In addition, also, our website actually was on the CSL VMs here, so it was running purely on those VMs. Then we had gotten a notice that like, oh, our VM's actually getting deleted. So one of the things I did was log into it as sudo, use VMware to create a full OS backup of that, and then I could just run the server also on my own computer, and it would be exactly the same. And then from there, I deployed it to a physical machine.
So VMs sound pretty cool. Why don't I just like live my entire life on a VM? Like, why do I just use my normal OS?
Well, you could, and then that would add a lot of extra isolation to what you're doing. And that is a good practice. The main reason why is because it also does take away from your full system resources. So on a laptop, that's a lot harder to just always do everything inside a VM, because you already have limited resources that you just can't unsolder, like the RAM and put in new RAM, stuff like that. And you also have limited hard drive capacity or SSD capacity. But from there are benefits to running things inside a VM, but for anything like heavily graphically related, like games, they don't play well in VMs or anything that needs a lot of CPU power.
Theoretically, could you like install a virtual machine on like an external drive or a USB stick and like plug it into any computer and it would work? Is that feasible?
Into any computer, no, because you would need to have the hypervisor layer present. So unless you were able to run, like say VMware portably on the USB drive, that would be a thing. But even then, I don't know how you'd be able to get the hypervisor running inside of whatever operating system you just plug it into. But you can store VMs on external media and then play them back from there. So then you don't necessarily have to use your own current storage on your machine. Cool. So if anyone doesn't have any questions, now is when we're going to move on to the workshop portion of this. So